DAX is a formula language commonly used in Microsoft Power BI to create custom tables, calculated columns, and measures. If you learn and master DAX pretty well, you have control over your visuals and reports, which allows for better performance and flexibility within your Power BI report. So welcome back to Excel Island, where the goal and objective is to learn and master the Microsoft Power BI tool over the next 100 days. Today is day 43. We've been learning consistently over the past 42 days, so you can catch previous live streams, previous learning or previous lessons on the live stream tab on the channel. So 4 days ago, we started the DAX function in Power BI, which is a new course on this journey. So each live stream, probably 4 live streams, focus on a course. And in each course, there are 4 chapters. So if you really want to move along with me, just look at the first 4 live stream, which is focusing on a particular chapter in this whole career, trying to learn and master the Microsoft Power BI tool. So in today's live stream, which is the last day of this course, which is the DAX function in Power BI, we'll be looking at another powerful functions in DAX, which are the iterating functions, iterators or iterators function like sum x, average x, max x, and so many of them like that. That's what we'll be focusing on in this last day of this course. So far so good. We've covered when we started learning the DAX function in Power BI. We've covered setting up DAX models. We're actually using DAX to create data models within Power BI. We also look at DAX and measures. That is creating calculated columns and measures with DAX. We also look at the filtering functions in DAX, which are the counting function, like the calculate function in DAX, the filter function in DAX, the cost filter function in DAX. We also look at count X, count rows, distinct count, and a lot of other functions like that in DAX. So today, as a final day, we'll be looking at the iterating functions in that. There are also a set of powerful functions that you need to understand while trying to master and learn DAX within Power BI. So welcome back to the channel. So also all data set exercise files, Power BI files that I'll be using to learn is linked under the YouTube description. Do make sure to download those files and practice along with me. So without further ado, let's jump back to learning and welcome to day 43. I hope to see you on day 100. Don't forget to support the channel by hitting that subscribe button and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. So let's head back to the DataCamp platform. You can see we're actually on DAX functions in Power BI. If I go under the career track real quick, so you could see all what we've been learning so far. And when we started this learning journey, this habit of learning live streaming, or this learning idea, so I started with the data analysis in SQL career track. So you can catch those previous live stream on the channel on SQL. Then we are on data analysis in Power BI. And definitely when we finish the data analysis in Power BI, we are moving on to the next one, which is data analysis with Python, which is also one of the ways I'm trying to upskill myself and get more tools to my stack as a data professional. So let's look at data analysis in Power BI so far. We've covered quite a lot. It has 17 courses estimated for 48 hours of learning, but we've definitely spent more than 48 hours of learning so far. Definitely more than that, probably close to that. So we started with introduction to Power BI, then we moved on to case study in H. So this was the last course we took, and we're actually on these DAX functions in Power, which is the 10th course out of 17 courses. That means we are moving at a good pace. So I'll just continue from the DAX function in Power BI part, which is the last chapter in this course today. Definitely we're moving to intermediate DAX. Looking forward to learn more concepts in DAX in this part of the course. So let's finish and finalize with this DAX function in Power BI. So welcome back to the channel. Don't forget to support the channel by hitting that subscribe button and put on the notification bell so you'll be the first to know whenever I go live. So let's this last part of this DAX function in Power BI, which is iterating functions in Power BI. So this chapter covers the core concept of another powerful set of DAX functions, the so-called iterating functions. You will explore iterations with exercises focusing on ranking and iterating your data. So let's see what we have to learn.
Hi again. Another powerful set of DAX functions are the so-called iterating functions. Iterating functions operate on a row level, that is the row context, to iterate over each row in a table to perform some sort of expression. Typically, iterating functions end with an x, such as sumx or averagex, where the x stands for expression. Because you can specify an expression instead of a single column, iterating functions allow for more advanced calculations compared to aggregating functions such as sum or average. To illustrate how iterating functions work, let's revisit our calculate column example from Chapter 1, where we calculated cost by subtracting the profit column from the sales column. This newly created column was then utilized to calculate the total costs using sum. Note that this requires creating one column and one measure. The same result can be achieved with one line of DAX while also simplifying the data model. The sumx function takes the fact table as first argument. From there, the expression, sales minus profit, is performed at the row context. The end result is the same, but without having to create an intermediate column. In order to control the filtering aspect of this function, we typically use a filter function within the iterating function in order to filter down our desired table to our desired values. In this example, we are using the filter function to trim down the fact orders table to only contain the eastern region. This intermediate table is then passed into the sumx function to calculate costs. When we visualize this total costs east sumx measure, we can see that only the east values are shown due to the filter function taking precedence in the filter context. Another useful iterating function is the rankx function. This function takes a given table and ranks the rows by a given expression. Take the example where you want to rank the regions by their total costs. The region column is part of the dim sales table, and the intermediate function all is used to evaluate all rows across a table. The result, split by region, looks like this. Note that if all wasn't included in the calculation, every region would be ranked as 1. This is because the function would only rank among the values shown within the query context of the visual, being the filtered region in the table. As a result, every region would be the only and thus highest category to rank. Lastly, let's discuss briefly the use of operators in DAX. Comparison operators are used to compare values when a Boolean expression is needed for an argument, such as in a filter. Note that the strict equal to operator returns true when the two arguments have the same value or are both blank. Then there's the text operator for text concatenation by using the ampersand symbol. Finally, logical operators are used to combine Boolean expressions. A double ampersand is an AND condition. In the example shown, we are evaluating the return of both conditions for city and return. Only if both conditions are true, then the entire expression returns true. The double vertical line represents an OR condition, where either 1, 2, or both conditions must be true to return true for the entire expression. In, followed by curly brackets, checks if an expression matches any value in a list of values. Let's test what you remembered from this lesson.
Testing lesson knowledge in poor, great, awesome. That's funny. So DIY iterating from DAX syntax. You are asked to write a calculation that sums the total sales, but only for the province, Alaska, and Hawaii. You can do this without manually tinkering with slicers or filters. So drag each line of code to write the measure total sales sum X in the correct order. So we want to create a total sales sum X in the correct order. Okay. So the total sales sum X, that is the name of the function of our measure. So we want to use the sum X function. Okay. Total sales. Since it is sum X, we're going to wrap it in total sales. So sum else, this is sum X referring back to a measure, total sales. Then the total sales is probably a sum of the total sales. But then to filter the total sales to only city, to only province in Alaska and Hawaii. That's interesting. Oh, hold up. I need to understand why this will be coming first before the total sales measure. Since they want to filter this total sales to only sum X the cities in Alaska, the state or province in Alaska and Hawaii. Hmm. Oh, is it the filter that's going to come first? Okay, understood. So the filter is going to come first while using this with some X. So optimal code ordering, having a good conceptual understanding of how DAX syntax is structured will help you write complex calculation doing the exercises. Know that as best practice, indentation should be used in Power BI when you start a new function. I think that's interesting to see. Those are the filtering criteria. So the filter is going to come first. Some make it as well understood. Okay. So let's move on to the next year lesson.
In this final video of the chapter, I'll first show you a quick tip to tidy up and organize your created meshes. When you have a large number of meshes, it makes sense to group them into subfolders to keep a nice overview. You can do this in the model view. Select a measure and choose a display folder name. After pressing enter, the measure will move to this newly created folder. You can drag other measures directly to this folder or create new folders as you like. With that settled, let's have a look at iterating functions using this report. We have a table with actual, budget and forecast amounts, split up by year on top. Underneath, I want to create a table of the sum of actual amounts only, split up by product category name. We could drag the amount column to the product category table and add a filter on that visual to filter out the budget and forecast values, but that is not the most efficient way, since that requires all data to be loaded and then filtered to show only what you want to visualize. A better alternative is to use the filter context to filter the actual values using a measure. Let's create a new measure and call it actual transaction amount. Use SumX to iterate the sum over all rows of the amount column, filtered by actual as the scenario name in the fact table. Adding this new measure to the table, we can see that the total amount over all years corresponds with the total amount in the upper table. That means that our formula is working. Great! The reason why I added this second table is because I'm now able to rank the actual transaction amount column. You could sort a column by clicking its header, but with longer tables, it becomes more difficult to see which category is the 5th, 9th, or any other rank. This is where the rankX function comes into play. Let's create a new measure called actual transaction rank with rankX ranking the DIM product category table by the actual transaction amount and add it to the table. It seems that all product categories are ranked equally among each other. This can't be right. What happened is that the rankX function ranked the actual amounts using the query context, which is by product category name in this table. Since all product categories have only one amount per category, each category will be the only and thus first ranked category. By wrapping the product category dimension table inside an all function, we override the query context and can filter correctly using the filter context, which compares actual amounts over all product categories. Great! Now we see which categories are in the top 5 of best-selling products. Time to try this yourself.
Oh, great. Let's get our answers. Okay, let's practice with iterating function. So iterating functions are great for performing computations row by row and should be used when you don't want to aggregate all values at once for computation. In this exercise, you are trying to find out the profit ratio for a given employee. The profit ratio is a performance indicator in business analytics that tells how well someone or something is performing. For the profit ratio, we need to perform a row-wise analysis to divide the total profit by the total revenue. So if you've lost any progress, so let's open our exercise file, iterating functions. Okay, that is coming up. So create a new page called employee analysis. So create a measure called profit ratio that uses average X function to provide an average over the fat sales table while dividing profits by total sales. This measure represents the average profits ratio per sale. Okay, let's go back a little bit. Okay, so let's create a new measure. So this was from our last live stream, which is day 42. We were actually asked to we created a total sales measure and percentage total sales chiller for this calculation. This percentage total sales chiller, and we use that in the visual to create a map visual that shows the total sales or count of item stock by state of province. So we actually created a function, a measure called count of chiller item by stock item key using this calculate function and a cross filter function from yesterday. In the live stream yesterday, I had a technical issue that it cuts towards the end of the lesson. So this is the solution to that yesterday's live, which is day 42 live stream towards the end of the video. And the map visual here, which you are just using the location, state of province, and the count of chiller items as our bubble size to get the vision. So that's, by the way, let's create a new page. I'm going to call the page employee analysis. Employee analysis. Employee analysis. So for this, we need to use average X function. It now says create a new measure called profit ratio. Let's create a new measure called profit ratio. Hold up a minute. So that uses average X function to provide an average of the fat sales table while dividing profits by total sales. While dividing profit, do I have a function called profit here? We don't have any measure called, we have total sales, which is the total sales formula here, DAX measure here, which is just sum X. Then we have a function, a measure called profits. No, we don't. Okay. By dividing profits. Profits from where? Let me see. So let's go to the fat sales table. Do you have a profits column? Oh, we have a profits column. We have a profits column here. We're going to be dividing the profits column by the total sales. Okay, well understood. So we're going to be dividing the profits column by the total sales measure. And our total sales is a measure. There's not a total sales column here. There's no total sales column in our table at all. But we have a total sales measure, which is just summing. The total sales measure is summing the total excluding tax, which is this column, summing this total excluding tax here. That's quite interesting. Okay. Okay, let's give it a shot first. Then if we make a mistake, we can iterate. That's the essence of the iterator function. So new measure, which is going to be called profit ratio. Profit ratio, which is equals to an average x. Average x equals to average x. So the table, calculate the average expression, which is our fat sales table. The fat sales table. So our expression is going to be with average to provide an average over the fat sales table while dividing profits by total sales. That will be profits. The profits column, fat sales profits divided by total sales. I can use the divide function like this. No ways. I could just use the divide profits by total sales measure. Total sales. So let's see. That's absolutely correct. So we actually use the average x function to divide the sales profits, which is the column, by the total sales. This is also a column of the total excluding tax from the what? From the first sales table. So we just skip the process of actually mentioning this whole table in this our profit ratio calculation. So we just use total sales then. Now says this measure represents the average profits ratio per sale. Okay. Format this measure as a percentage. So it is actually a percentage. Okay. Now says create a table visual of profit ratio by employee to answer the question on the next step. So table visual, let's do a table visual. So let's drop the employee, all the employee names and their profit ratio. Uh-oh. So the profit ratio is almost the same thing, 53, 53, 54, 53. Oh, okay, let's see if this is correct. It says which employee has the lowest average profit ratio? Lowest average profit ratio. Or let's sort it. I could just sort this. Let's sort by profit ratio. We have to sort it. Sort ascending. So the lowest, I think lowest is this employee. Hudson. You can see Hudson had the lowest. Because let's just sort descending. So you could see that Hudson had the lowest average profits. Let's see. That should be Hudson. Great, we nailed it. Impressive use of iterating function. By using iterating functions, we don't introduce unnecessary intermediate measures in the measures table. That's interesting. So we nailed that. So we could see the average, the profit ratio of each employee in percentage. Okay, so the next instruction says more iterating functions. So your manager is pleased by your current employee analysis and asks you to dive deeper by looking at the average discount rates given per order by employees. Okay. Since the retail price and selling price, unit price are known, the retail price and selling price. Okay, let's check our fat sales table. We have to make sure where are we looking for that information. It says your manager is pleased by your current employee analysis and asks you to dive deeper by looking at the average discount rates given per order by employees. Since the retail price and the selling price, which is the unit price, okay, we have the retail price that the products were gotten and the selling price, the actual amounts that the products are being sold for are known. can calculate the given discount, so we could know the difference. Probably if there's a discount by subtracting the unit price by the retail price and dividing it by the retail price. This expression is perfect to use as an iterating function so that you don't need to create an intermediate measure first. So let's look at the table. No, we're not looking at the model view. We are going to the table view. Oh, I think we have the unit price. This is the unit price of the each products. Where is the selling price? So this is the unit price of the products, and this is the retail price. You can see the retail price was at least for 19, it was $19.44, and unit price is $13. Okay. Probably there's no discount, there's no much discount here. Okay, let's see. So this is the unit price, this is the retail price. So okay, this is the actual price the product was bought, and this is the selling price the product was sold for. Exactly. Oh, I've missed that up. So so that's the opposite of what I'm supposed to say. That's interesting. So let's move on first. So retail price, understood. Okay, retail price is the amount the product was gotten for, and the selling price is the unit price. Okay, interesting. Now understand the difference. Can get confusing at times. Quantity sold, unit price it was sold for. Okay, interesting. So let's move on following the instruction. So the instruction now says you can calculate the given discount by subtracting the unit price by the retail price and dividing it by the retail price. We're going to subtract the unit price from the retail price and divide it by the retail price. This expression is perfect to use in an iterating function so that you don't need to create an intermediate measures first. So average discount. So look at average discounts. Let's see. So if you've lost any progress, close any open report and load the iterating function completes from the exercise folder on the desktop. Okay, create a new measure called average discount rates. Let's create a new measure called average discount rates. So I'm going to call this new measure average discount rates, which is going to be average X. Average X. So our table is going to be the fat sales table. Okay, use average X on the fat sales table while subtracting the unit price from the retail price. Okay, so fat sales table. Then our expression is going to be a subtraction of the unit price from the retail price. So that will be, our expression is going to be retail price from the fat sales table minus the unit price so minus the unit price, okay, comma, but we need to perform one more steps by dividing this subtraction and dividing the difference by retail price. So, okay, now let's give it one more. Let's divide by retail price. The retail price here, okay. Let's see if that is going to work fine. Let's see. Okay, no error was given. Now let's see that. Format this measure as a percentage. Let's format it as a percentage. They create a scatter chart visual with average discount rate on the x-axis and profit ratio on the y-axis, color by employee on the y-axis, color by employee. Okay, the color by the employee. Okay, a scatter visual, scatter chart. Let's open a scatter charts. This is a scatter charts visual. So we want to drop the average discount rate on the x-axis. So this is the x-axis. Average discount rates on the x-axis. Okay. Then the profit ratio on the y-axis. On the y-axis, we also have the profit ratio. Profit ratio on the y-axis. Then our color, that is dim employee, will be the color. Definitely the legend will be dim employee. Okay. Let's see. Ooh, this doesn't make sense at all. This average discount rate doesn't make sense. I see the percentage is way over line. Way over. So let's look at our average discount calculation first. Seems there's an error somewhere. So let's go back one more step where we actually calculated it says create a new measure called average discount rate using average X on the fast sales table while subtracting unit price from retail price. Okay. Okay, let's change this to retail price there. Unit price from retail price and divide the result by retail price. Let's see. Ooh, it is now way. Okay. I think the division is causing a little bit of trouble here. So I'll be negative. So I'll be having negative for sure. But we need to divide that calculation and dividing the difference by retail price. Okay. Okay. Hold up. So I need to wrap this in a quotes before actually dividing by retail price. Let's see. So negative. So the mistake was switching. So okay. Oh, this is better now. So I've seen you can see the percentage now looks better than before. So you can see now. So I figure out my mistake there. So while dividing, I need to make sure I'm closing this subtraction part of the measure. The first sales retail price minus. You can see we are asked to what? To while subtracting unit price from retail price. That's a retail price minus unit price. I'm subtracting unit price from retail price. Then dividing the result of this by retail price. So I'm getting my result. I think this is much more better now. So not knowing what you want to subtract can be confusing at times. We can iterate along the way. Okay, so now let's see this scatter plots better. So it says, now let's move on. From the measure as a percentage, our percentage is now better. As a percentage must not be over 100%. But to confirm that, let us just drop this in the table visual real quick here. And let's see our employee. Let's bring in the employee, the table visual, and let's bring the average discount. You can see summing up to 33%. Doesn't really matter though, but let's leave that by the way. And let's confirm our calculation here. Okay, let's look at the instruction. The instruction now says, what are the lowest profit ratio? How high was his average discount rate? So let's look for Hudson. This is Hudson. This is Hudson Onslow. This is Hudson always. Where is his average? So how high is it says how high was his average discount rate? So his average discount rate. This is him here. I think this is him here. No, that is Jack Potter. This is him here. Yeah. So his average discount rate was 33.09%. 33.09. Let's log that in. 33.09%. Oh, we knew this. That means our calculation was absolutely correct. You see? So kind of funny. Let's look at this one more time, side by side. This is the guy here, Hudson. Only what it has 53.16% profit ratio. Then his average discount rate was 33.09%. It's a little bit high though. The discount was probably the guy is giving more discounts than any other person there in any other employee. That's good to know. So let's move on to the last. I think this is the last challenging rank X. So knowing the difference between how to subtract can be really confusing at times. You have to be pretty smart about it on the subtraction part. So let's solve the last part of the challenge of the analysis, which is the rank X function. Since we were already ranking employees during the previous exercise, let's use the rank X function to quantify this more easily. Wrap up this chapter by averaging all employees according to their average discount. By ranking, rather, we want to rank all employees according to their average discount rates. Okay, so create a new measure called discount rates ranking. Okay, let's create a new measure called discount rates ranking. Okay. New measure. We call it discounts rate ranking, which is going to be equals to discount rate ranking is going to be a function of rank X. Rank X. So the rank X, the table, and the expression that we want to rank. Let's see. Okay, so let's pay attention. It says function to provide a ranking of all the employees listed in the dim employee by their average discount rates. Don't forget to include all within 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 the within the function to rank all employees of the dim employee table. Okay, so we want to use the function I want to rank all the employees. So I'm going to mention the table, which is the dim employee table. That's the table all employees are. And the expression is going to be based on this average discount rates. So average, no, the discount, what do I call that? Average discount rates, comma. We have to make sure I'm not ranking each employee on their own. But let me do that first. Let me do it wrongly first. I'm going to do it the right way. If I log that in, our measure shouldn't have any challenge. So I want to rank them based on, okay, let's go back a little. Let's follow the instruction. So add a discount rate ranking to the table visual it seems that there are no non-salesperson among the employees as well, since this doesn't have a profit ratio. Okay, hold up. So you say create a measure called discount rates ranking that use rank X function to provide a ranking of all employees listed in the dim employee by the average discount rating. So the dim employee, let's see that. I could just come here and drop in the average discount rating also, which is this. Let me get rid of this real quick. I'll just find somewhere to put it here. So if I bring in the average, this new ranking, oh, you can see that it is ranking each employee wrongly. But let me just remove this average ratio, this profit ratio, try a discount rating also, which is totally way off. Let me remove the discount rating also. Look at the ranking here. And some employees are having 11111. But let's just include the all function as part of the discount rating first. So I'm going to rank all employee against themselves. Going to be all. And I'm going to close the bracket also. And let's see. Oh, you can see. I can see that it is not ranking them differently. Which is not easy to see though. But let's move on. Following the instruction. Let's see. So I've done, don't forget to include all within the to rank all employees of the employee table. I've done that. Now add a discount rating rank to the table visual. You see that there are non-salesperson among the employees as well, since it doesn't have a profit ratio. Go to the dim employee table in the data view and check which column specify whether an employee is a salesperson or not. Okay, so when I drop this new calculation, this ranking calculation, discounting the number. No, I don't want that. If I drop it here, the ranking is kind of way off. We're having multiple numbers there, so 100. Probably some employees are not salesperson, while probably some employees are the manager, while some employees are not the manager. I think that is the challenge here. So if I go to the instruction, it says add the discount rate ranking to the table visual. It seems that there are non-salesperson among the employees as well, since this doesn't have a profit ratio. Exactly. So let's go to the dim employee table. Let's go to data view. Go to the dim employee table. You can see, so if the employee is a salesperson, it's going to have a value of 1. If the employee is not a salesperson, it's going to have a value of 0. That means we are actually ranking all employees against each other. Salesperson and non-salesperson is being ranked against each other, and some of them, they don't have a profit ratio calculation since they are not an employee. So they won't be in the fat sales table. So the employee that actually made those sales won't be in the fat sales table. Exactly. So that's why the ranking is way off here. So what's the solution? Now let's move on to the solution. Return to the report view and use the classic dashboard filter on the table visual to only include a salesperson equals to 1. Okay, that's interesting. So now let's go back. We can just filter them easily using our old filtering technique here. So let me just bring in back the profit ratio that we have here. So you can see the profit ratio and the discounts. Let's look at the discounts calculation back. You can see that it is ranking all employees against each other, even if you're not a salesperson. And as a salesperson, if you're not as a non-salesperson, the record of the employee won't be in the fat sales table. And we're actually using the dim table to perform this ranking. So to do that, I'll just filter it right on the window here. I'll just add a filtering criteria here. I'll just use the old filter table here. I'll say is employee. I'll just come here and say okay, I think I can add, let me add one more data field here. I'm going to add, where is employee? Is salesperson. If I go to the employee table, this salesperson, I'll just add it here and say is salesperson, and I use basic filtering. So if it's a salesperson, I'm going to have equals to 1. So you can see now the ranking is better now. Interesting. So we have our filter here. So it says return to the report view and use a classic dashboard filter on the table visual to only include salesperson. Okay, on the table visual, not the report. Filter on this visual. Okay. Filter on this visual. Okay, now let's see. Discount rate ranking. Ooh. So which employee is ranked 5th by average discount rate ranking? The ranking is still not correct. 5th, I can't see 5th here. 5th, so I'm missing something in my discount sales ranking by average discount rates. Let me look at my calculation first. So my calculation is using the average discount rating. Exactly. I'm using all dim. So I need help here, but let's figure this out really quick. Okay, so my calculation, my ranking is also be 1, 2, 3, 4, not all this number I'm seeing here. Let's get rid of it first. Let's bring it back. Still the same thing. Okay, let's go back to the measure and figure out what is happening here. If my average discount rating, let me begin my average discount rating first. Because if my average discount rating calculation is absolutely correct, then why is not the ranking not correct? The ranking, okay, let's see what is wrong. Discount rate ranking, which is rank X, all employee. Let me remove the all employee function first and see if I rank both number against each other. So let's try the formula again one more time to be sure. So it says create a new measure called discount rates ranking that uses rank X function to provide a ranking of all employees listed in the dim employee by their average discount rating. Okay, of the dim employee table. I want to rank all employees of the dim employee table. So I need to mention the dim employee. Okay, I need to mention the employee. Oh, hold up. I think I didn't mention the hold up. I need to mention the column I want actually. I'm referencing the dim employee instead of a column here. Let me look at the dim employee real quick. The employee column is here. So I need to go back here. Oh, my mistake was actually ranking the old table rather than ranking the actual. Okay, hold on a minute. Rank X. Okay, so let me just include all immediately. So rather than ranking all the dim employee, I'm going to rank only the employee table, employee column. Okay. Then comma. So I've gotten it of, I'm going to rank the discounts. Where's my measure? The measure is going to be discount, profit ratio, average discounts. So I'm going to close that up. Then my expression is going to be the average discount rating. Then close that up and let's see now. Aha, it is so my mistake was actually referencing the old table and actually referencing the employee column from the old table, from the new employee table. So the fifth person should be Sophia Intin, which is absolutely correct right now. So you can see you should make a mistake and you correct yourself. That's the best way to learn. So if you just use, so we filter it to only show the employee. Let me go back to this visual. If the employee is salesperson, so that's what we did. We actually filtered the whole employee list to only show the salesperson. So the fifth person there is Sophia Intin. Sophia, I think that's correct. This Sophia, yeah, this Sophia. Great, we nailed it. So that's quite interesting to see. Remarkable ranking skills. Having a rank column helps with visualizing the order of a variable and allows you to filter out a top 5, for example, easily. Interesting. So we nailed the course easily without any challenge.
Congratulations! You've expanded your DAX knowledge in this course. Well done. You saw multiple applications of DAX. You discovered how DAX is used in measures, calculated columns, and calculated tables. You also learned about the importance of row, query, and filter context when writing DAX functions. You expanded your general toolbox with new knowledge about implicit versus explicit measures, and you learned how to use quick measures and variables. Later, you discovered a ton of new functions to set up and analyze your data model, such as calendar, calculate, related, filter, and cross-filter. Finally, you discovered iterating functions. We hope to see you iterating on your Power BI knowledge in other courses.
That's very interesting. Oh, we did it. So we finished this DAX function in Power BI. We're able to nail all the challenges so far. So we're moving next to the intermediate DAX functions in Power BI. Definitely going deeper. I think we are going into the logical functions in DAX. That's quite interesting. But let's say that, so that will be on tomorrow's live stream, day 44. I will see you on intermediate in Power BI, which will be looking at the logical functions, row level security, table manipulation filters, and time intelligence functions. A lot of cool stuff to learn here, like the switch, if, exploring switch, and so on. All right, so that'll be all for this live stream. All right, so thanks for staying to the end of the live stream. So if you found value in this learning journey with me, trying to learn and master the Microsoft Power BI tool, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I will see you on tomorrow's live stream, which is day 44 live stream. Looking forward to see you all the way till day 100. Bye for now. Have a wonderful day. And go catch up on previous lessons on the channel and practice upskill your Power BI skills.